Um, 1 over 0.5 is actually 2. 0.5 as a fraction is 1/2, so I have 1 over 1/2. That's the same thing as 2. So I just need to multiply everything in this matrix by 2. So I'll go ahead and do that. So that's 1.8, 1.1, 0.8, and 1.6. Okay. So this is the inverse of I minus A. Okay, so now the last thing I need to do, according to my formula, is just find I minus A inverse times D. And this will be X according to the formula. So I got to multiply this with this. So let me rewrite it. 1.8, 1.1, 0.8, 1.6, and then I have 10, 20 for D. So I'm going to multiply these two matrices together. This is a 2 by 2. This is a 2 by 1, or yeah, 2 by 1. So the result will be another 2 by 1. The first entry is take the first row times this. So 1.8 times 10 is 18. And 1.1 times 20 is, what, 22? Hope I did that right. 22. So what's 18 plus 22? Is that 40? 30? 40, okay. Arithmetic in my head is hard sometimes. All right, should be 40. And again, if I'm making any mistakes, please just yell at me. 0.8 times 10 is 8. 1.6 times 20 should be 32. So 8 plus 32 is also 40. That worked out nice, assuming I didn't make any mistakes. So it looks like, assuming I did everything correctly here, which no one's yelling at me yet, so maybe we're good. The production schedule is 40-40. This is our answer here. X is 40-40. So I need 40 units of lumber and 40 units of oil to meet the demand of 10 units of lumber and 20 units of oil. That's a lot of lumber and oil to produce this much lumber and oil. But that's how it goes sometimes. Okay, cool. So I'll pause here again for questions. It's gonna be one of those days where I talk more than usual. But so, any questions? Okay, so let me, now, this is just for 2 goods in an economy. Let me just briefly discuss the procedure for any amount of goods in an economy. You know, we might have, basically we can have as many as you want. You know, the real economies in the real world are vastly complicated. We could have as many goods as you want. So let's just talk about the general case here. It's basically going to work exactly like the 2 by 2 case, but I just want to make sure that I outline all of this for us. It'd be a good summary. So we have an economy with n goods. N is just some positive whole number. So for us, it'll basically be 2 or more goods. So n is how many goods we have. So we're always going to have our technology matrix. Technology matrix. I always denote this by capital A. And I'm going to use this sort of abstract matrix notation. That was weird. Matrix notation that I used before, where I just describe what the entries are. So this is just the entry in the ith row and jth column. Again, it's exactly like I said in the 2 by 2 case. Aij equals the amount of good I required to produce 1 unit of good J. So if I number the rows, if I label the rows and the columns by the goods, then the entry in the ith row is just how much of good I that I need to produce 1 unit of good J. So compare this with what we did in the 2 by 2 case. There were 4 entries, and again, two goods. And we saw that we filled it in exactly this way that I'm describing here. We'll have X. So this is called the production schedule. So I'll give it the name over here. We have the production schedule, which we call X. This is a column vector whose entries are variables, perhaps, x1 through xn, where xi is just amount of good I. So each variable represents one of our goods in the economy. And we're asking how much of that good we need to produce to meet some demand. And then speaking of that, we have the demand vector, which is another column vector that we'll call capital D. And this has a bunch of numbers in it, maybe D1 up through Dn. So again, there's one for each good. And Di just equals the demand for good I. The demand for good I. So it's how much of each good that we want. Okay. Now, in a typical, so these are always our pieces, these are the ingredients to one of these problems. And in any given problem, you're basically going to be asked to do one of three things. I might give you a problem that just says, write down the technology matrix from the information given. And I've already sort of explained how to do that with some basic examples. The same kind of procedure works for bigger matrices. So I won't harp on that too much right now. You'll get to practice that. The other two harder things that you'll have to do is either solve for X like we just did in that last example. You might have to solve for a production schedule, in which case you are given D and you have A and you're going to use them to find X. The other thing that you might have to do is instead find D. You might have A and be given X and then need to find D. And so those are just a little different. But those are the kinds of things that you're going to be asked to do with these kinds of problems. And so to finish off our summary here of what to do, let me write down those formulas again. Formulas just said X equals AX plus D. This is our main formula where everything else is based off of. It sort of represents the economy right here. And then if you have to solve for X, I already wrote down that formula. It was X equals I minus A inverse times D. So this is one formula you'll definitely want to know. And then in the other situation that I described just a second ago, you might have to solve for D instead. So it might be that you need to find a D if you already have A and X. In which case, if I wanted to solve this equation for D, it's not so bad. All I have to do is subtract the AX from both sides. That'll get D by itself. So we end up finding out that D equals X minus AX. Equivalently, by factoring, I could also say this. D equals I minus A times X. These both say the same thing. There's no difference. So if you compute it this way, or if you compute it this way, you'll get the same answer. So it's up to you which of these is more appealing to you. It's up for you guys to decide. They'll both give you the same answer. But here you go. You want to know these formulas because you'll be using them over and over again to solve these problems in this section. Okay. Cool. So any questions? So we have like 18 minutes left or so. So our options are either, I could let you guys spend the rest of the time working on an activity, or if you guys want, I could do another example. I don't know what would be more helpful for you guys. So I don't know, do you guys want to see?
Can you do another example, please? Like some things I don't like. I mean, I don't exactly understand everything, but can you do another example, I guess?
I mean, I could definitely do another example. That's no, I don't mind. I might just steal one from the textbook and work through it. I could certainly, so yeah, I could do another example. Maybe a good thing to show you would be solving for D or something. Maybe I could do both. Maybe I should do a bigger example. I don't know. Oh, yeah, here's an example. Okay. So we're going to have an economy with 3 goods. So let's just up the ante a little bit. Make it slightly more complicated again, but it doesn't really change the overall process at all. We have 3 goods. I don't know. How about lumber, oil, and I don't know, steel. These will be our 3 goods. Lumber, oil, and steel. Okay. So let's say it takes the following. To produce 1 unit of lumber, it's going to require, let's see, what do I want? I want 0.2 lumber, 0.6 oil, 0.2 steel. This is all to produce 1 unit of lumber. Yeah. Okay. Now to produce 1 unit of oil, I'm going to need, so maybe it doesn't take any lumber at all now in this new economy. It takes 0.1 oil and it takes 0.4 steel. This is to produce 1 unit of oil. And maybe over here I'll write, it takes 0.6 lumber, 0 oil, no oil at all, and then 0.3 steel, all to produce 1 unit of steel. Okay, so this is our setup in this economy. I have all these numbers. We need to know all this information. So some of these problems are kind of long-winded when I try to write them down because I have a lot of information I have to give you, but that's okay. So this is how much it takes of each good to produce 1 unit of lumber. Here's how much it takes of each good to produce 1 unit of oil. And here's how much it takes to produce 1 unit of steel. This is all given to us. And here's going to be the statement of the problem. So here's what we're going to do. Suppose I have a production schedule that says X equals 30, 20, and 40. Then what is D is going to be the question, basically. I said it another way, what demand can we meet with this production schedule? So we're going to find out what demand we're able to meet with this production schedule based on this information given here. So, okay. So the first thing you should do is let's collect all this information in our technology matrix. Let's write down the technology matrix. So I have all this information written down in front of me. So I'm going to recollect all of this in a technology matrix, which will be much nicer to look at than this. Okay. So maybe I'll leave this up as I go, sort of illustrate what I'm doing. So let's get the technology matrix A, which is a big 3x3 matrix. And let's just agree that the order of my goods are lumber, oil, steel, right? Because I've written them in that order over and over again. That's our order. So it's going to be lumber, oil, steel, lumber, oil, steel. So how much lumber does it take to produce 1 unit of lumber? That's 0.2. How much lumber does it take to produce 1 oil? That's 0. 0 lumber to produce 1 oil. And it takes 0.6 lumber to produce 1 steel. So I wrote down this information sort of backwards for what I had in this example written down. So if you read in your book, you'll see an example like this, but everything will be kind of flipped. But that's okay. The way I'm going to do it will still be correct. It would just basically be a different problem. So anyway, the second row is represented by oil. So now I'm going to ask how much oil does it take to produce 1 unit of lumber? That's 0.6. It takes 0.1 oil to produce 1 oil. And it takes 0 oil to produce 1 steel. And finally,